Good afternoon, and welcome to the closing session of the virtual summit, Technology and Solutions for Next-Gen Communication Systems. I'm Graham Kilshaw once again from Lectrix, and I hope you've enjoyed and learned a lot from today's program. Our final webinar today is titled Riding the mmWave with High Performance Filters, Full Bands and Narrow Subbands, featuring once again Roger Merrill, the Director of Technical Marketing and Business Development for RF Ceramic Filter Products at CTS. Welcome back, Roger. Let's begin the final presentation today.
Hello, everyone. This is Roger Merrill. Thank you for joining me regarding our webinar, Riding the mmWave with High Performance Filters, Full Band and Narrow Subband Filters. First, let me point out that I've got my contact information provided below, and if you need more information on a specific product family, don't hesitate to reach out to me. Much of the information we're describing here is not available on our website, and if you need specific data sheets, you'll need to reach out to me. On the top of the slide, you can see in the green box would represent our filter, our mmWave filter, operating in the, say, 24 to 40 gigahertz band. This particular filter, as we're proposing it, would be located not between the power amplifier and the antenna, where you're constrained by physical size and you're constrained by tolerable insertion loss, but instead it's after the mixer up converter, but before the splitting network that goes to the various power amplifier and antenna elements array. This requires then fewer filters as well and makes you insensitive to those constraints on size, performance, insertion loss, and so on. Additionally, as you can see on the bottom, there are instances where you may also need an IF filter, intermediate frequency filter, that would be used between, say, the transceiver and the up converter. And we have a number of families of filter products that are suitable for those applications. Then on the lower right, you can see applications where they're not strictly mmWave. They could be considered microwave, such as X-band or KU band applications. In general, the same families of filter products can also address these applications as well. The first family that we're going to describe is the mmWave family. These are the smallest and lowest cost of the filters that we offer. They are fully shielded surface mount components. They are optimized for handling the full 5G NR FR2 bands. This would be, for instance, the N257 band, which is nominally called the 28 gigahertz band, the N258 band, which spans from 24 and a quarter to 27 and a half gigahertz, and important to note that's also adjacent to the water vapor band, so it requires some extra special close-in rejection. And then there's the N260 band, which is nominally called the 39 gigahertz band. All three of these bands would be in what I would call a universal footprint, meaning they will all be the same form factor and the parts can be interchanged in a design that can accept any of the bands. The MCB family is a second family that we offer. This is a higher performance, higher Q filter family that is meant to support, in general, narrow subbands of the 5G NR FR2 bands. For instance, if you have an 800 meg channel or a 1 gig channel or frequency allocation from a customer service provider, and that particular network operator only wants their passband allocated and provide as much close-in rejection as is possible into the neighboring subbands within the 5G NR band. Here we've shown two examples. The MCB 2800A illustrates a 1 gig passband in the middle of the N257 28 gigahertz band. And it shows that it achieves better than 40 dB rejection at 1 gig away from the passband. So you're talking about a very sharp rejection at millimeter wave frequencies. So this can be extremely valuable if you've got a mobile network operator who's insistent upon not offering the whole band, but only offering the subband for which they are licensed. I've also illustrated the MCB 1412A, which is operated at roughly half of the frequency. In some applications, this would be for an X-band or KU band microwave application, certainly usable there. It can also be used at a very high frequency IF for a millimeter wave application. I've shown in the slide the printed circuit board layout of the surface mount component. The component is fully enclosed and shielded, and so you can see the compact form factor of this product. The MTB family is a new family. We've extended our monoblock technology to support yet higher frequencies. I've shown just one example here, which is around a 10.5 gigahertz center frequency. And you can see in a very small form factor what excellent performance is possible with this monoblock technology. It's important to note that this is highly customizable, and we can offer many different options in these frequency ranges. The final family that we're going to describe here is the UPB family. This family originally developed and is still supported for TDE bandpass filters for conventional 5G applications. So whether that's band 40, 41, 42, 43, 48, 77, 79, so on like that. But we've extended this family to go all the way up to 7 gigahertz. And if you have an IF frequency that's somewhere in that, say, 2 to 7 gigahertz band, then this is likely a suitable IF filter family for these applications. And we can customize this for any IF requirements you have. The one thing that's important to recognize, though, is that if you're aiming to support, for instance, an 800 meg or a 1 gig wide passband, that it's critical that you choose an IF center frequency that's high enough so that you don't have an unreasonable ratio of passband bandwidth to center frequency. And in general, a suitable ratio is around 20%. So here, for example, you are seeing an 800 meg wide passband centered at 5.3 gigahertz. That would be a suitable passband.
Thanks, Roger, and thanks for wrapping up for us a great day of presentations in this virtual summit by CTS. Members of the audience, if you'd like to ask a question of Roger, now is the time to post those questions. Simply go to the Q&A button at the bottom of your screen. Whilst you're thinking of your questions, you will be able to download slides of each of the presentations today. Simply go to the link that you received for your registration or you can use one of the orange buttons you can see at the bottom of your screen now as well. If you have any questions for Roger or his colleague Ronan Cohen, who featured earlier in the day, you can obviously reach them through the ctscorp.com website, or Ronan Cohen or Roger Merrill on LinkedIn. I'm sure you can find them there. Okay, it doesn't appear we have any questions for this particular presentation. Roger, any final comments before we sign off?
Sure. Yeah, so one, I want to emphasize that these mmWave and these IF, as well as the companion IF filter products, are generally not listed on the website. You will need to reach out to me if you want details on these. They're very new at this point, but we do already have some customer design wins on these. Another thing that's important to emphasize is, and this is true generally of RF ceramic filters, including these mmWave filters, is they are highly customizable. So just because you haven't seen the exact pass band or center frequency or performance that you're looking for, that doesn't mean we cannot serve that need. In fact, we likely can. Of course, we like to see high volume applications, but one of the desirable attributes of the ceramic filters is that they do not, like a bar or F-bar filter or something like that, have high mass costs or anything like that. So even moderate volumes are, in fact, feasible to offer solutions for. Obviously, we have to make it make economic sense for us. So there may need to be NRE charges in order to satisfy your custom requirements, but be assured we can satisfy the requirements that you have. Okay,
great.
I think that's it.
Thanks, Roger. Thanks to everybody in the audience today for your questions. We had a few hundred people watching live today. So thank you, everybody, for your time. I hope you found this very useful. If you have any suggestions for future content that you'd like to see from CTS in these particular areas of timing and filtering for 5G and IoT, please let them know, or me. I'm Graham Kilshaw from Lectrix. I hope you enjoy the rest of your day. Bye for now.